Ladies and gentlemen, good evening. Now we have come to part 3 of the style guide for TypeScript, so let us just jump right into it. The TypeScript style guide is placed at google.github.io styleguide tsguide.html. If you are writing TypeScript, then this is definitely something that you need to read at least once. In my opinion, of course. So, and if you are too lazy to read all of it, then just go to all of the red blocks and then see if that is something that you might have a habit of doing. And then, if not, then you just scroll down to the next section. But I would definitely recommend you to read this, especially if you come from Java code to JavaScript and to TypeScript, then I would definitely recommend you to read this best practice. There is a lot of, I think there's a lot of good tips and tricks, and you could also avoid bugs in your code if you follow all of these tips and tricks right here. So what the last time we talked about functions as the last thing that we actually have to, how to define functions, also functions with functions inside them. And now the next thing is expression bodies versus block bodies. Use arrow functions with expressions or blocks as the body as appropriate. So this is about when to use the arrow functions and when to use the block. You can see right here. Here we have use. Here it says bad. Use a block if it returns a value of the function is not used. If the return value of the function is not used. So this means that here we should use curly brackets around the console.log because the return value is not being used to anything, so we're not returning anything. So let us see when it's good to use these arrow functions right here. And so this is a good example because here we actually use the curly brackets. Here we have this is the arrow function in here. And this is called a block because we are using the curly brackets. If you're not using the curly brackets, then it's just called the body. Again, here we have some good code. Let's just see why. We have the curly brackets. It's good, and then we are returning something in the end. So always use. Okay, the short idea here is to always use the curly brackets. Then you're fine. Here we have a fun example where we are rebinding this. So in general, don't use this because it can be difficult to see what is this. Here we have a function, click handler, and that is bad because what is this in this context right here? And here we set this text content equal to hello, and then let's see how we use it. We use it like body document.body.onClick, and then equals to the click handler. And this means that this in this situation is actually document.body, and that might not be what we actually expected and what we thought right here. So instead, what we can do instead is actually to create an arrow function like this, or it could also just be a normal function where we actually reach the document.body.text content instead of actually reaching, instead of just writing this. This is much more readable than this code that we have up here. The other code was also fine, but this is much more readable because we can actually see what is being set right here. And we have the same here, document.body.onClick, and then we can actually set the function. Then we call the function right here. And here we have the content of that function right here. We set e and then the text content to something, and we use an argument. We use a parameter to this function right here. So yeah, so don't rebind this. That is one good practice to follow. Then we have the arrow functions as properties, which is a bad idea. We should just create arrow functions and then do whatever we want to do inside those arrow functions at the place in the code where it actually makes sense, and then not create this references to them. So here we have a good example right here. Here we have a handler which equals to an arrow function like this, and here we actually call this this function right here. It's okay to have functions on the class, of course, and here we call that like this. It is much more difficult if you do something like this, or it's worse if we do like this. We set this handler to this does listener. Now we suddenly have a reference between these two, while in this situation right here, then we have a new error function which is actually created that then calls this one right here. So that is much cleaner code, and it should be easier also to read actually. Then we have some event handlers. Event handlers may use error functions when there is no need to uninstall the handler, for example, if the event emitter is by the class itself. So let us try to see some examples on the event. Here we have an event listener that we add right here, and here we use the error function, and it's used a lot. When especially with the event listeners, then it's almost always error functions. Of course, it could also be a type of function that is named as an interface. That is of course totally up to you to define that. Especially when you have if you're dealing with React and Typescript, then you can in many situations actually create an interface named props, wherein and then you can also create another interface where you actually have your event listener mentioned there. Maybe you have a function with a special signature, and then there can then be calls upwards in the hierarchy. So, but here we have an event listener, and it's an error function. That's good. And then we have some bad code down here. Here we have some add event listener. And then we are binding. You see here this listener.bind that this. It's also a bit difficult to read what is actually going to happen. So we have a hard binding right here. Here it would be much nicer to actually create an error function and then call whatever we want to call inside that error function that we have right there. Then we have automatic semicolon in insertion. Do not rely on that. We need to explicitly terminate all statements using semicolon. So that means we need to use semicolon. This prevents bugs due to incorrect semicolon insertions and ensures compatibility with the AC support, with the limited AC support. So always use, to get out of that, then just always use semicolon in the end of the line. It is actually optional. You don't have to, then it will actually automatically be set in with this functionality right here. Automatic semicolon in insertion, ASI. Then we have tsignore. Do not use tsignore. It superficially seems to be an easy way to fix a compiler error. But in practice, a specific compiler error is often caused by a larger problem that can be fixed more directly. Yeah, that is tsignore. That is if you want to suppress some errors, and of course we should never do that. You should fix the error itself. Of course, that makes sense. Then we have type and non-null assertions. So here we have some bad code. Here we have x as foo, and then if it is the type, then we are actually calling the method right here. And here we also have some backcode. Here we say if y is being is available, then we can actually call bar on the y. What could we do instead? We could actually say we can have an if statement right here. If x instance of foo, and then x foo. This, if you're a Java developer, you would like to see this, of course, also instead. That is exactly like almost how you would actually write the code in Java. And then we have if y. That means that if y is not undefined, if there's some kind of value in it, if it's not 0, if it's not a blank string, then you would actually call y.bar on you would actually call the bar function on y. And in this situation right here, then we are when you write this exclamation mark after y, then that means that we actually we think that y is something, or we force the compiler to think that y is something. So that means that if it's undefined, then we get an error in our code right here. That's not good. Here we actually ask, is y actually something? Then we call bar on the y. Here we just say we know that y is something, so just call that function on y. And of course, it's much nicer code to write it like this. Then we avoid errors when we run the code. Type assertion syntax. Here we have the type assertion must use the as syntax. So that means we set as foo. That means that now we know that the type is now being asserted as a foo, then we can actually call length on it. And the reason why we do that in JavaScript and in TypeScript is because it's we are dealing with, many times we're dealing with objects. Sometimes we get a JavaScript object over the line also, and then we can actually convert it to something that we think it is, and then we can call the functions, and we can also access the properties on it. Then we have type assertions and object literals right here. Type annotation, that is colon and then the type. Instead of using type assertions, let us try to look at a bad example that we have right here. Here with the question mark, that means that it might be something. It could also be nothing. It cannot be. It could be undefined and null. When we have this one right here, and we say that it is a type string. Here we have that is interface. Then we have the foo equal to, that is, here we define object. Here we say that this key equals to 1, 2, 3. That's a number, and here we set it to a string, and then we cast it as the interface right here, and then we have a function right here where we return an object, and we return this object right here, and we actually return it as the type foo right here. So what is the right way to do this? This is the right way. Here we have the interface right here, and we have a constant right here, and here we declare the type to be foo. Instead, we did not do that up here. Here we just assert it afterwards, but we should actually declare it on the same line as where we declare our object variable or variable name. Then we should actually say which type is it, and in this situation it is the type foo, and we have the interface for foo right here. And when we are calling this function right here, then we say that this function returns the type foo. We do not need to then assert it afterwards, because it is automatically converted into the type foo, because of course it follows the foo restrictions which we have right here, bar and bash. If we return something that does not contain any parameter inside the foo interface, then we will get an error in our code. But this is the way to write it. We should never, as soon as you write something when you assert it to some type, then you should always think, could I have used the colon instead? That's actually the short version of that best practice right there. Then we have the member property declaration. Here we create an interface. That is the good way to do it. Here we have the bad way to do it. That is, here we're using commas. That's not good. We should use a semicolon instead. So don't use the use semicolon and don't use the commas inside your interface declaration right there. Optimization, compatibility for property access. This is bad code. Code must either be non-quoted or quoted access for any property consistently across the whole application. So that means these are two different ways where we actually get access to the property. Here we are actually using the quoted way to access the property, and here we are using the dot. The dot annotation not annotation, the dot way to get the property. We should always use the same way to get access to the properties, and of course I would definitely recommend you to use the dot like this, because then it's easier to read, and it's also you will also get some more help with your in your IDE. It's easier to check the type. Then we have optimization compatibility for module objects imports. Here we have some bad stuff. That is import star as utils from utils. This means that you just import everything as utils, while up here you actually say that you want to import method 1 and method 2, and this of course it's much more optimal. So if you want to write optimal code, then you would actually do this instead of just importing everything like this. Something about exceptions, something about enums. Always use enum and don't use const enum. There's no reason for using const enum because enum is already immutable. Debugger statements, yeah, we should not use that at all. at least not in production code. So then we have some decorators. That is when you write the @ sign on top of something. Yeah, we generally want to avoid decorators, so because it's an experimental feature. So try not to use decorators in general. If you come from the Java world, then that would be very difficult because you use decorators for a lot of things, especially if you use Spring Boot. Source organization, what do we have here? Then we have the modules. We have the import path. Must use path to import TypeScript code. That means that we are using we're using the relative dot or the 2 dots to show that we go up one folder. That means that we actually show we use our imports like this. That means that if we are referring to something that is higher up in a hierarchy, then we need to use 2 dots and then the folder name and then the folder, then the subfolder again right there. That's just how we do the imports when we're dealing with TypeScript. Namespaces versus modules. TypeScript supports 2 methods to organize code: namespaces and modules. But namespaces are disallowed. So we should not use namespaces. We need to use modules instead. Your code must not use namespace foo constructed. Namespaces may only be used when required to interface with external third-party code. Okay. Do not use namespaces. So we should not use namespaces like this. Instead, we should just export whatever we want to export. So this is a default export that we have right here. Oh, sorry, we have the default export down here. We should actually use, we should not use default exports. We should use a specific export instead. And then we should just, import that. And that is because the default exports, they do not give any name. We can actually choose to rename it. When we import it somewhere, then we can choose to call this foo for Mike instead, if that's what I want to. But while you are importing, if you export this one right here, if you want to import it, then it gets the name foo. You can make sure that it gets that name right there. So if you're using default exports, change it as soon as you see it to a non-default export. Export visibility. TypeScript does not support restrictions on visibility for exported symbols. Okay. Mutable exports. Export let is not allowed. It also does not make sense that you want to change something that is just exported. There's actually a way to get the mutable export by doing this export function get foo, and then we can actually return some kind of value that we have up here. Every time you import something, then all of the code that is actually in that file will be run, just so you know. So if you want some Java code inside a file, and then you have an export, then you will both get all of the code run, and you will also get the export afterwards, just so you know that. So best practice is not to try to run code in classes. It's actually just to define your classes and your functions, and then export whatever you need to whatever is needed by other files. Container classes. Do not create container classes with static methods or properties for the sake of namespacing. So we should not do something like this. We should just export individual constants and function. We should just export whatever it is that we actually want to export instead. This is a container class. We have created a new class just for the sake of organizing our code a little bit better, and that is not good. We should just export it directly. And I think it's just because it looks ugly, actually. Imports. There are 4 variants of import statements. We have the module imports, something star as foo from, that is the TypeScript imports. Then we have destructuring. This is the most used one, and this is the one that I use the most. I take something from that file that has been exported, and when we do it like this, then we can actually not change the name. Then it will get this name. It has the name something in my class that actually uses something from whatever we are importing. While if we use the default import type, then we can actually, instead of writing something right here, I could just write Mike, and then I could write from, and then the file name right here. And that is the downside of using default exports. That we should not use default exports. And this is very ugly side effect. If we import some code that just runs a lot of stuff, then we don't really control what is happening, because a lot of things could happen in this file right here. But I would definitely not recommend that. Then we have some good stuff right here. We have choose between two options as appropriate, and I like this one right here. Import, and then we use a destructuring, and then we take that from one file. Of course, we could also get something right here like this, and then we get that from. And again, we're renaming that as ng, and we're getting that from. We're getting the whole module. This is a way to where we get the whole module as ng from this library right here, Angular core. So, and then there's a long talk about, not long, then there's talk about module versus destructuring. When do we use one, and when do we use the other one? Overlong import statements of needlessly namespaced names. So they actually say that the way that I actually favor is not good. When there's a lot of, when we're importing a lot, then we should just use star, and then there's table view. And then we can actually access all of these things by using tableview.item. I was actually not aware of this, that this was bad practice. I've done this a couple of times actually. So this is better. Import everything as table view, and then we can actually access all of these items by using tableview dot and then something right here. That is called the module import instead of the destructuring import. I'll remember that. Yeah, there's a lot of good tips and tricks right here. So in the style guide, that is a reason for them to create it, I guess. Renaming imports. Yeah, then we can rename it as something else. I don't like that. Code should fix collisions. Yeah, should fix name collisions. Okay, if there are name collisions, I can see that. If we already have something inside another file, of course, then we have to rename one of them to something else. It's okay, yeah, renaming imports. But if there's no collision, then I would definitely recommend that you just keep the original name. It's much easier to see through. Imports and export types. And what do we have here? Import type foo from then the foo file, and then we have export type bar. Yeah, okay, that's because we use the keyword type. We should not use that. We don't need that. So just use regular imports. There's no need to actually create type definitions. The type like that. Organized by feature. This is a very, very good point right here. Instead of saying yes, what I see in a lot of code is that people organize stuff by using views, models, and controllers. And that is, I really don't like that. I like it instead when you use it when you organize your code by features instead. So you can actually see in your products folder, you have everything regarding products, and in your checkout folder, you have all of your files regarding checkout, etc., etc., etc. It does not matter if they are a view, model, or a controller. The file should be located, organized, in the context where they actually fit in. So I really like this one right here. I really like this line. This is something that everybody should read twice. Type system, type inference. Yeah. Then we have the this is a number by default. Here we have okay. So they say that you do not need to mention. We should not mention the type when we are setting it at the same time, because it does not do anything for readability. It just shows you that we are a bit insecure maybe on our JavaScript or on our TypeScript, because TypeScript, of course. because we are mentioning that this is a Boolean, but it's actually very normal and very human, I guess, when we start with this constant and we say, okay, I know it's a Boolean, so I just write it's a Boolean, and then after that, I find out that I actually want to set it in the same line, so then I just set it to true, and then I actually did not have to mention that this is a Boolean. And the same thing right here. We do not need to set it. We do not need this part right here. We can just create a new set, and then maybe set a string value inside. So there's a string. And we can also mention the generic. On the set right here. So then we have here we have the right way to do it. New set, and then the generic is right there. Return types. Whether to include return types is up to the author, up to the code author. I'm happy for that. I like to put return types on everything. Also, even though that you can actually see that what is returning 2 lines further down, or maybe in the same line, I really like to use the return types. Null versus undefined. Typescript supports both null and undefined. Undefined is if you have not said anything about what the value is. Null if you want to specifically say that this is now null. It can also be created as a union type like this, similar with undefined. TypeScript code can use either undefined or null to denote absence of a value. There's no general guidance to prefer one over the other. Many JavaScript APIs use undefined. You can choose whether you want to use undefined or null. Just know that per default undefined will be used if you have not set it to anything. Nullable undefined type aliases. So this is like, you can actually say that one type is, it is okay to set one type to null by writing a pipe and a null after the type. Then it's okay that it could also be null. You can also write the same with undefined. And here we have some examples. So this is a bad example. Here we have a type where we say that this could be a latte, americano, or undefined. And this is not good, because instead we should write type equal to coffee response equal to latte or americano, and then in our class right here, then we say that what we are going to return from this getter right here is either the coffee response or the undefined. So we actually move the undefined from the type down to the return type. And this is a very good point actually. And it's very easy to fall in this trap right here. When we define the type, we also say that it can also be undefined. Don't do that. Then the functions that actually return and use this type right here, it can be defined, so it can also return nothing, undefined. So optionals versus undefined. So here we have optionals, because that's another thing in TypeScript. You can actually use optionals like this. So you have this question mark right here. That means that it can actually be nothing. It can be undefined. In addition, TypeScript supports a special construct for optional parameters and fields using the question mark. And that means that if you do this, that means that then it can actually be undefined, and it can also have this value right here. This optional parameters implicitly include the undefined in their type. So that means we do not need to mention undefined. It's just we already have done that by writing that there's the question mark right there. You should, but definitely, as it also says, you should try not to use undefined. Try just to set it to a value. It can be a blank value if you want that. To do that, it can be something else, something meaningful than just having undefined. Undefining and null in general, they are very difficult to handle. So try not to have them in your code at all by setting everything to something. Structural types as nominal types. Okay. So here we have some bad foo right here. That is a... So here we have not said that this has a type. We're just defining an object. So this means we're defining an object with no type. Instead we should actually say this is the foo type, and we are defining these properties right here. It's much better. That is the TypeScript way. This is the JavaScript way, where you just just create objects, and then inside your head you know that this is foo. But when the next developer comes, then they do not know that this has this foo data structure behind it. Interface animal. Yeah, we're using a lot of interfaces when we're dealing with TypeScript. Here we have a function that makes a sound where you give it an animals as an argument. Yeah, it's cool. This is just code Very nice code right here. Here we have a horse. It's a type animal, and it has a sound, which is neigh. And we can also see that the interface up here, right, it has a sound and it also has a name. So horse does not meet the type contract of animal, and that is because it does not have the name. And that is a problem, of course. So here we will get a type error. That's a cool thing about the TypeScript. We get all errors inside IDEs. We get them compile time and instead of runtime. Yeah. And when I say compile time, this is because, of course, TypeScript is being compiled into JavaScript. So here we have an animal, which is actually this is an animal that actually has the structural type animal, and it actually meet the contract, which says name and sound. And the dog has a sound and name. That's fine. Interfaces versus types. When should we use types? When should we use interfaces? You should not use types. You should use interfaces. That is a short explanation right there. Why? These forms are nearly equivalent, so just choose interface. That's actually what they say. Yeah, just choose interface, then you're good regarding this guide right here. Then we have array, and those arrays are actually the arrays can be created in many different ways. We can create them by just using the type and then the square brackets, and that is the best way to do it. That is the best way to create them. Here we have some bad examples of arrays. We have a const array and then type right here. The syntax sugar is shorter. And we have the same up here. Then we have the read-only array right here. And here we have the read-only as a keyword right here. And then we have the array right here. So we should actually use this way to create arrays, even though that we actually also can create them the other way. If we have more than one, if an array can have more than one type, then the best practice is actually to use the array. It's to use the array like this, and then say in the generics that this is a string or number. Then we should not use the short way of doing it. This is I think this is details, but of course we should try to go for this standard that I have right here. Then we have indexable. Okay, then we have maps and hash, and we have dictionaries. We have that in JavaScript and TypeScript. Then we have a more meaningful label for the key. So it means that we will actually have like a key and then a value like this. So this is the bad way. This is the good way that we have right here. So here we have the username, which is a string. So and then we have a number for that. So this is the two different ways of giving labels for the key. Mapped and conditional types. We have record, partial, and read-only. I don't know if there's that much to say about that. Then we have any type, TypeScript any. That is, it can subtype of all types. So it can have any type. It does what it actually says right here. Let us see if we have a good example of that. So here we have that. This is a more specific type, but yeah. So we have any, and then we can providing a more specific type, use interfaces, and inline. Yeah, that's because we should not use any. We want to be type safe, of course. Using unknown over any, the any type. Okay, what is the bad one right here? Const danger any. So this is any type. Then we should use unknown instead, equal to value. And why is that? Use the built-in type unknown. In that situation, it expresses the concept and is much safer as it is. It does not allow different arbitrary properties. Okay, yeah. So we should use unknown if we don't know what type it is. It's also more saying because it says that we actually don't know. While any, it means that it could mean that we're just too lazy to actually define the type. So unknown is much better. I totally agree. Suppressing any int warnings. Yeah, that is not. Yeah, the lint warnings. Let us not dig into that. Tuple types. Okay, this is the bad way of creating a tuple. Here we are actually creating an interface called pair, and here we are having a first and second. And we do not need to do that when we are dealing with tuples. Then you can actually just create a tuple like this, like left half, right half, and then we actually split in half my string. So this means that we're actually returning a tuple like this. So this is a tuple when you use a squared bracket, and then you can have a tuple with two values. You can also have one with 10 values if you want to. That's the point of a tuple. Here we are actually creating a real interface, so that means that we have a real object instead. So this has nothing to do with a tuple. Wrapper types, Zafir, blah blah. That should never be used. Okay, we should never use the primitive wrapper types right here. So we should just use the primitives instead. Also because we should never invoke them but new, and the reason for that is actually because they have unwanted side effects. For instance, if you create a new boolean with the value false, then it actually gives true. That's a bit weird. Return types, only generics. Yes, always use generics. That's why we use Typescript and not just JavaScript. We are dealing with types. We want the types. Consistency. Be consistent. Yeah, we should try to do the same all the time. That's actually it. We came through the whole style and the whole code guideline. I think it's definitely worth reading. There's a lot of good tips and tricks. So if you haven't read it yet, then and if you're new to TypeScript, then definitely read all of it. And yeah, write some good TypeScript code. If you're a Java developer, then it's a lot of fun to create TypeScript. Then you would also enjoy actually creating front-end applications, because you have the TypeScript types, and you feel a bit more safe than with the weird JavaScript where you can do whatever you want and there's no types. Thank you very much for watching. Have a great evening. Hope to see you again soon. Bye-bye.